In 1937, a researcher published the results of a 25-year study involving 500 of the world's most successful industrialists. While the public consumes Think and Grow Rich as a work of motivational self-help, the original research was gathered as a series of technical observations on resource acquisition. The text functions as a technical manual for a cognitive operating system, detailing the steps required to compile abstract ideas into physical assets. Andrew Carnegie, the primary source of this data, hypothesized that high-variance success followed a replicable algorithmic formula. Carnegie's objective was to extract this formula from the minds of industrial tycoons and standardize it for mass application. Examining this 1937 formula today reveals the exact cognitive architecture required to effectively deploy modern synthetic intelligence. Applying the Carnegie formula in a digital context requires translating its three core variables into modern systems terminology. Hill's concept of definiteness of purpose acts as the objective function, the rigid input dictating how energy is processed. Persistence is the iteration loop, treating failure as latency data to refine the attempt. Finally, the mastermind represents distributed compute, networking processors to scale cognitive capacity. This architecture allows for exponential returns by replacing linear hard work with a nonlinear, scalable framework. The first operational phase requires establishing a non-negotiable objective function to filter all incoming opportunities. When Edwin C. Barnes arrived in Orange, New Jersey, he lacked capital and influence, but he possessed a fixed mental target, a partnership with Thomas Edison. Barnes ignored employment offers to focus on his specific model of partnering with the world's most successful inventor inside this laboratory environment. He accepted a menial wage and performed unimportant tasks to embed himself at this desk, maintaining proximity to the target while waiting for a viable market vehicle to appear. That vehicle was the Edison dictating machine. While the existing sales force saw a product that was difficult to sell, Barnes recognized the technology as the precise mechanism needed to execute his partnership. A rigid objective function forces the user to ignore irrelevant distractions until the specific environment required for success is synthesized. Within this system, a plan is a hypothesis, and defeat is merely data indicating a flaw in the current model. R.U. Darby famously quit his mining operation after the gold vein he was following disappeared. He sold his equipment and returned home, unaware that the ore was located exactly 3 feet from where he stopped. Darby's error was interpreting a geological fault line as a permanent boundary. A junkman bought the machinery, hired a mining engineer to interpret the fault data, and recovered millions in ore. Henry Ford demonstrated the correct use of the iteration loop during the development of the V8 engine. Ford demanded an 8-cylinder engine cast in a single block. His engineers informed him that such a design was physically impossible to manufacture. Ford forced the team to run the iteration loop for a full year. He ignored the initial impossible output and commanded the team to continue refining the process until the block was successfully cast. In Hill's formula, persistence functions as a strict algorithmic refusal to accept a failure state as the final output. A single human brain is a bounded processor with restricted compute capacity. Carnegie's solution to this hardware limitation was the mastermind principle, the coordination of knowledge and effort in a spirit of harmony. Coordination between 2 or more minds creates an emergent network synergy, a third mind that possesses greater processing power than the sum of its individual parts. Carnegie used a staff of 50 specialists to manage this industrial output. This network allowed him to manufacture and market steel at a scale his own technical knowledge could not support. Similarly, Henry Ford overcame his lack of formal schooling by networking with specialists like Thomas Edison and Harvey Firestone, essentially building a human computational cluster. The most successful founders are those who efficiently distribute their cognitive processing across a coordinated network. Hill expanded the mastermind concept internally through a mental simulation he called invisible counselors. He ran nightly simulations where he consulted with the mental impressions of historical figures like Abraham Lincoln to solve complex strategic problems. In 1937, accessing a physical mastermind of elite thinkers was restricted by high costs and geographic limitations. Large language models remove these barriers by providing a simulated network of elite expertise available for the cost of a software subscription. A single founder can now instantiate a synthetic cabinet trained on the world's most comprehensive strategic and technical datasets. Synthetic intelligence allows anyone to bypass the 1937 bottleneck of accessing elite human capital. Modern prompt engineering is the current method for setting an objective function. The precision of the prompt dictates the quality of the synthetic network's output. Prompt refinement serves as the iteration loop. You treat flawed AI responses as feedback data needed to adjust your constraints for the next query. Deploying an AI mixture of experts architecture scales the mastermind principle, allowing a single user to synthesize solutions that previously required a physical boardroom of executives. The Carnegie algorithm, when run on a synthetic mastermind, creates a scalable path to wealth that was previously restricted to the industrial elite. By applying these 1937 principles to modern AI tools, you can process ideas into reality at a speed Carnegie could only theorize.